Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and this will be a larger update since it has been 2 weeks since the last news update. So let's jump right into it. Podman 5 is here. It's the following article here. And since students in this lecture are required to Dockerize their application, and Podman is a drop-in replacement, they can also use Podman or Podmanize it. I'm not sure if this is the correct term. So Podman 5, released in March 2024, is an upgrade that includes a rewrite for Windows and Mac, significantly improving hypervisor support and performance. The key updates feature a rewrite of Podman machine command for better stability and the introduction of Apple hypervisor support, making Pasta, that's the name, the default for rootless networking and replacing BoltDB with SQLite for database management. Also, this release enhances the Docker compatibility. Word of caution, most things that run in Docker will also run with Podman, although there is an architectural difference. I was talking about these differences in the lecture. I also tried Podman, so I tried to switch from Docker to Podman. That was roughly 1 year ago, but it failed to generate images that I was deploying at the customer side. The customer had their own infrastructure. I was generating images with Podman, and at the customer side, those images could not be read. But I think with Podman 5, now it's a good time to revisit this and try again and see if it is a drop-in replacement. Next, I have the following article. It's Do You Really Need Kubernetes? It's the following article here. And as always, my short answer and also the conclusion of this article is it depends, or maybe. This blog post critically examines whether organizations truly need Kubernetes, weighing its advantages against the complexity it introduces. While Kubernetes offers significant flexibility and a uniform platform across various environments, it also demands substantial management overhead and can lead to a strict way of doing things in its own framework, potentially overlooking simpler, more direct solutions like managed cloud services. Its portability also introduces a unique kind of locking to a specific architectural and organizational paradigm. And this can create a narrow focus where all solutions are forced to conform to the Kubernetes environment rather than selecting the most appropriate tool for a given task. And the author suggests that for many less complex systems, that allow for autonomous cloud-first development. There are other alternatives like AWS, Elastic Container Services, might be more beneficial and stressing the importance of evaluating real business needs and total cost of ownership before committing to Kubernetes. And one key sentence, this is down here. I think this is kind of an interesting sentence. While getting started with Kubernetes can be fairly straightforward, doing it right and managing it effectively over time is challenging. And organizations invested in Kubernetes often require dedicated experts or platform teams to manage central Kubernetes clusters and associated tools from the ecosystem to relieve development teams from an excessive operational burden. So, in the end, as the author also concludes, should you switch to Kubernetes or not? The answer is it depends, as always. There are benefits, there are advantages, disadvantages, and you need to consider the use case, and once you have all the facts, you can make an informed decision. The next topic is about the attack that caused a lot of attention. It's the following article or timeline here. This caused a lot of attention as it was a sophisticated attack to install a backdoor in SSH all around the globe. And this critical vulnerability has been discovered in the XZ utils, which is a compression library and is commonly used for open source data compression in many Linux distributions. This vulnerability stems from a sophisticated backdoor mechanism introduced maliciously into the software. And this backdoor allowed for remote code execution, posing a significant security risk, especially for systems that expose SSH to the internet, and many services do that. The backdoor was not directly inserted into the source code of XZ, but it was hosted on public repositories hidden in source code tarballs that was used for testing. And with this method allowed the malicious code to remain undetected during the usual code review process, because it was some test cases that run. Once these tests were run and this malicious code was executed, this backdoor worked by interfering with the function name resolution process during system initialization and replacing certain SSH authentication functions with malicious versions. And this allows attackers under specific conditions to execute arbitrary commands on the affected system before authentication is complete. And this incident underscores the inherent vulnerabilities that can emerge in complex distributed systems, utilizing numerous interconnected services essential to many organizations' operations. Such systems, especially those relying on interconnected services like SSH, they need to adopt strict security protocols and conduct regular audits to address and reduce these risks. And although XZ is a compression library and not directly used in SSH, the interconnected nature of modern systems can create unexpected linkages that exploit vulnerabilities in seemingly unrelated components. Very nice timeline about the hack, what happened, what has been discovered. Take a look at it. It's a good read. The next article is about JSON and the importance of interoperability. It's the following article here. And the article is about what even is a JSON number. And the following actually table, let's just jump right to it. This table shows the problems with JSON and numbers. So JSON is the numbers in JSON, they are defined in various specifications like ECMA 404 or the RFC 8259, and is defined as the numeric value that may include an optional sign, fractional parts, and exponents. And despite its simple definition, JSON numbers can be complex in practice, differing in precision and range across different programming environments, and due to their reliance on native data types like double precision floats. Using JSON in different programming languages can lead to different results. And when working with cryptocurrencies, as an example, then we use always strings for numbers. Then we can parse those manually, since if you have a huge integer, as in this example here, then you see already where the problem is. So this huge integer is larger than an int 64, and in Go, for example, it will be converted to a float 64. Also in Rust, in JavaScript, it will be converted to a 53-bit number, and there will be rounding issues. And if you have rounding issues, then you may lose precision. And when you lose precision in a cryptocurrency project, you may lose funds. And this is something your users won't be happy about it. Interestingly, Java here, if I look at this table, everything is converted correctly. Probably Java is battle tested and rock solid with that respect. Still, if we do also with Java cryptocurrency projects, we typically always go with the number is a string and we do the conversion manually. The next article, the following article here, it's about caching and Docker. It is a guide for Docker layer caching with GitHub Actions. It discusses optimizing Docker builds with GitHub Actions by implementing effective caching strategies. It explains Docker images as stacks of layers, promoting reusability for faster builds. And this post outlines 3 caching methods using GitHub's native cache, using a registry-backed cache with inline, and a separate registry cache method, each offering distinct advantages and limitations in terms of scope, size limits, and build speed. And this guide serves as a comprehensive resource for choosing the right strategy based on specific workflow requirements. So in Docker, I already mentioned this in the lecture, each instruction in a Docker file is treated as a layer and can be cached. This means that if the file or the underlying file hasn't changed, Docker can reuse the already generated data rather than rebuilding it or downloading the dependencies, and this speeds up the building process. So in this example, he starts with the typical Docker Compose file, and then looks at how can GitHub Actions be integrated. This is here with the build and push action. So he adds cache from, cache to. GHA stands for GitHub Actions. So this is one strategy. The downside, if you use GitHub Actions, you may have size limits and predefined eviction policies. So there's another strategy with registry backend cache. He then continues with inline caches. Here the cache 2 has the type inline. This has a problem if you have multi-stage builds that only the second stage actually gets cached. And the solution to that is the registry cache. Here we see type registry, where all the cache lines are being registered. The next article is about latency. It's the following article here. The author analyzes the latency improvements of the latest GNOME version 46 compared to 45 and showed that terminal latency significantly improved. GNOME 46 terminals have undergone significant performance improvements, particularly in reducing input latency, which makes them feel faster and more responsive. Through the use of a hardware-based testing setup, the input latency for various GNOME terminals was measured and compared. And here in this picture, we see this setup. Here we see it a bit better what he did, how he measured the input latency from key press to displaying something on the screen. And here is the measurement or the measurements. So we see here, for example, GNOME 45 with the GNOME console, and in GNOME 46, the same terminal application console here, we see an improvement of around 30 milliseconds. And to give you a notion on how fast 30 milliseconds is in networking time, so the latency, the round trip time from the base station to a Starlink satellite is roughly 33 milliseconds during peak usage hours, which I found in this article here. So here they found that it's 33 milliseconds. And this just to give you an impression of what it means that a console gets 30 milliseconds faster. And this is just for comparison. It's a comparison apples against bananas, but still it gives you a notion of what it means to be 30 milliseconds faster. The last article is about software architecture. It's the following article here. It's the software architecture of Threads, the X or Twitter competitor. And Meta developed and launched the Threads app. This is a text-first microblogging service in just 5 months by leveraging Instagram's existing monolithic architecture. And that this rapid development was possible due to the reutilization of Instagram's backend component and infrastructure, which included a large Python code base using a custom Django framework and some PHP components. The data is managed through Tau, which is a graph data model caching layer backed by a sharded MySQL database. And the transient data is handled by ZippyDB, which is a key value cache. And additionally, Meta utilized async serverless function compute platform for executing asynchronous jobs. And this tech stack enabled Meta to quickly iterate and refine threads using internal feedback to adjust the app's features. And despite the speed of development, this approach introduced significant technical debt, which Meta plans to address gradually as they continue to develop and separate threads from Instagram's infrastructure. So we covered lots of new topics since the last time I reported about news was 2 weeks ago. And you also may have noticed that I'm toying around with this teleprompter here, and I will check how it goes. And you also may have noticed here this new device. This is a teleprompter, which I'm playing around with it and see if it works better for recording these in the news sections.